Hello students, welcome back to CLARI Concepts and Listening Conceptual Learning. Today we are going to solve numerical examples of the topic called buoyancy. So those of you who have not yet gone through my lecture on buoyancy, where I have made you understand about the physical concept of why buoyant force acts and what is the amount of buoyant force that acts on a body, kindly go through that lecture first and then come back to this lecture on numerical examples. You will really enjoy this numerical. These are all really interesting numerical examples that I brought for you. Let us start. Example number 1, a 170 kg granite rock, density is given to you, is dropped into a lake. Okay, a man dives in and tries to lift the rock. Determine how much force the man needs to apply to lift it from the bottom of the lake. Now see, what it is given to you? It is given to you that there is a lake and the big rock of mass 170 kg. So I should say that mass of the rock is 170 kg. Let me put mr, and then density of the rock, let's say rho r is 2700 kg per meter cube. This is given data. Now when it is dropped in the lake, a man goes into a lake and tries to lift it up. Question is how much force a man has to apply on this rock to lift it up. So let us say right now the weight of the rock is acting downward. Because it is in the fluid, the buoyancy force will act upward. Now let us say the force applied by a man, let's say it is Fm. This will also be upward. So the force should be such that even the buoyancy force assists the force, it should balance the weight, right? So if you say at least the force should be, if I do the equilibrium equations, I should say that force of man plus force of buoyancy should be equal to the weight of the rock. That means force by man should be equals to weight of the rock minus buoyancy force. Question is how do we figure out? Because weight of the rock is very clear, mass of the rock into g. I know the weight. How do I get buoyancy force? First of all, let us calculate the buoyancy force. Buoyancy force will be equals to weight of the fluid displaced by the rock. That means mass of the fluid displaced into g. This will give you the weight. Mass of the fluid displaced means density of the fluid into volume of the fluid displaced by rock into g. This means, see, what is the volume of the fluid displaced by the rock? Because rock is entirely submerged into the lake. So whatever is the volume of the rock, the entire volume is displaced by the same is the volume displaced by the rock of the fluid. So this will be volume of the rock into g. Density of fluid is known to be because it is water. So this will be 1000. G I know. How do I get the volume of rock? You see, mass is given to me, density is given to me. So can I say density of rock will be equals to mass of rock divided by volume of rock? So volume of rock will be mass of rock divided by density of rock. Mass is 170. Density is what? 2700. So I'll just do the calculation. 170 by 2700. I'll get 0.063 meter cube. This is volume of the rock. So here density of the fluid is 1000, volume of the rock is 0.063 and G is 9.81. So what you will get is 1000 into 9.81. You will get 617.66 newtons of buoyancy force. Now you see this is the equation that you are looking for. So Fm will be equals to weight of the rock, I will put weight of the rock, which is mass of the rock into g minus the buoyancy force. So mass is 170 into 9.81 and buoyancy force is 617.66. So therefore Fm is equals to 170 into 9.81 minus 617.66. 1050.04. 1050.04 Newton is the force that a man has to apply to lift the rock. Let me check the answer. Yes, it's perfectly fine. So lift force by the man should be 1050. I hope you got this clarity, right? It's a practical real life example. Okay, let us go and solve another example. The volume and the average density of an irregular shaped body are to be determined by using a spring balance or spring scale. Now see, buoyancy can also be used to calculate volume or you can density of an irregular body, right? The body weighs 7,200 Newton in air and 4,790 Newtons in water. Determine the volume and density of the body. So what they have given irregular shaped body. When it is in air, it is giving you 7,200 Newton, and when it is in water, it gives you the value of 4,790 Newton. Now which means what? When it is in air, it is the actual weight of the body, right? So I will say the weight of the body is basically equal to 7,200 Newton. When it is in water, the spring balance that is measuring the force, basically it is measuring the force, weight is downward, buoyancy force is upward, and the tension force on the spring is, let's say, F. So the spring balance is measuring weight minus F. Why? Because in this case F plus FB will be equals to W. So the whatever force a spring balance is measuring, it is measuring buoyancy force, weight minus buoyancy force, right? So I should say that this 4,790 is the force. 4,790 is the force. Basically, this is measured by the spring balance, which is equal to the difference of weight and buoyancy force. So weight is 7,200. 4,790 equals to 7,200 minus buoyancy force. So what is buoyancy force? You take it left side, 7,200, you take this right side, so this will be minus 7,200 minus 4,790, this will be 2,410 Newtons. So buoyancy force you got is 2,410 Newton. What is buoyancy force? Buoyancy force means weight of the fluid displaced. This means mass of the fluid displaced into G. This means density of the fluid into volume of the fluid displaced into G. This means density of the fluid. What is volume of the fluid displaced? It is the exact volume of the rock itself. So let us say the volume of the body is V and then G, and this is FB. So now I know all the values. FB is what? Let's say FB equals to rho of fluid, volume and G. FB is 2,410. Density of the fluid is 1,000, that is water. Volume is not known to me and G is 9.81. So what is volume? Calculate the volume. The volume is 0.245 meters cube. Answer 1. You found the volume. Now, what else they are asking you? They are asking to find the average density. When you want to find the average density, density of the body should be equals to mass by volume. What is mass of the body? Can I say mass of the body is the weight of the body divided by G? So mass will be weight by G, and then volume is 1 by V as it is. Because weight is mass into G. So what is weight? 7,200. Then G is 9.81. Volume is 0.245. So 7,200. This is coming out to be 2987.55 kg per meter cube density. Answer. Answer 2. Let me check. 2987. Perfect. And volume is 0.245. So these are the answers. So I hope you got to you understood how to solve examples based on buoyancy, right? Let us solve another example. Consider a large cubic ice block floating in a sea water. So I have the sea water and the ice is floating on the sea water, right? Cubic ice block, so all the dimensions are equal. Specific gravities of ice and sea water are 0.92 and 1.025 respectively. So given data, I will just write the given data. See, specific gravity of ice is 0.92. So density of ice will be what? 0.92 into 1000, which is 920 kg per meter cube. Specific gravity of sea water is 1.025. So density will be 1.025 into 1000. So this is 1025 kg per meter cube. If 10 centimeter high portion of ice block extends above the surface of water, determine the height of the ice block below surface of water. Very interesting question. What they are saying is the the height of the ice block above surface of water is 10 centimeter, then determine this depth of ice block within the water surface. So let us first assume that the block has length L on both the sides, on all the three sides basically. This is a cubical block, so it will be L by L by L in 3 dimensions, right? So since a body is floating, always keep this thing in mind. Whenever a body is floating, the weight of the body is always equal to the buoyancy force acting on the body at this particular instant. So weight of the ice block will be equals to the buoyancy force. Weight of the ice block is what? Mass of the ice block into G equals to what is buoyancy force? Buoyancy force is the weight of the water displaced. So weight of the water is mass of the water displaced into G. G will get cancelled. Now what is mass of the ice? How can we find? I can find mass of the ice as density of the ice into volume of the ice. How can I find mass of the water displaced? I can find density of the sea water multiplied by the volume that is displaced. Yes. Now what is density of ice? 920. What is volume of ice? Can I say it is L into L into L? So L cube. What is density of sea water? 1025. What is volume of water displaced? It is L into H. See, this is different. Volume of water displaced is L into H. So this is L square into H. You cancel L square and L cube, so only one L will remain. So this will be 1025 by 920. You will get L to be equals to 1.114 H. You mark this equation number 1. Now you see, what is L? L is nothing but H plus 0.1. So I see why I am putting 0.1 because this is in 10 centimeter. I want values in meter always. Remember this thing. So I can write it like this. L is equals to H plus 0.1. 10 centimeter is 0.1 meters. So I'll put the value of this L 1.114 H over here. So this is 1.114 H. That is equals to H plus 0.1. You take this, this H on the left hand side. This will be minus. So 1.114 H minus H equals to 0.1. You take H common out and find out the value of H. So you will get 0.1 divided by 0.114. This will give you 0.877 meters. So depth of ice block inside the water is 0.877 meters. Let me check the answer. 0.877 meters, perfectly fine, which is equal to 87.7 centimeter. Multiply by 100. Clear? So I hope you got this answer and how to calculate the numericals of buoyancy. Thank you so much. For many such conceptual videos on engineering concepts and numericals, log in to our website clariconcepts.com. Thank you so much.